Hello and thank you for coming to check out this video. I'm going to be continuing my trace reading playlist, and I'll be going through this particular file here, the pKnane gateway with Xcoder. There's two different sets of logs in there. One is for the failure, which was my previous video, and this set of logs that we're going to look at is for the successful transcoder allocation. I'll be sure to put this link in the description of the video so that other people can come and download it if they want to go through the logs as well. And I'll go ahead and move that out of the way now. I'll copy out the path for the files. And then over in Notepad++, I'll hit Control-Shift-F and I can paste it in here, which I already did. Then we look over at the important information text file, which is found in with the traces. And we can see that there's the timestamp. This is for the failed call, and then the timestamp for the successful call is 21:53:28.417, and we have our calling party and called party information along with the transcoder. I'll take the number here and I'll copy that out and I'll put in the DD like we always do, DD equals and then the number, and close out the quotes. We get a number of different hits here. Now, this is why it's important to have your timestamps, so that way you don't want to look at all three of these different calls if you don't have to. And when we look at the timestamps, we can see the only one that starts with 21:53 is this one here. Therefore, we'll go ahead and start looking at this call. As always, I'll mark my digit analysis, and then I'll mark up my calling number as well as my called number. Then we'll scroll down a little bit to where we can find our CIs. I like to put on word wrap so that I can just copy it here. Now we'll go ahead and mark that with style token 1. And here in just a moment, I'll show you a trick that we haven't talked about just yet. We'll do a Control-Shift-F and we'll search on that first CI. Then we go down to where we can find it being associated with the second CI, just to make sure that we know what the second CI is. I'll make that a style token 2. Now let's do the Control-Shift-F again, but this time what we're going to do is put a comma and we'll put the second CI. Then we'll put those in parentheses. Let me update that to be the actual second CI. And now what we'll do is hit find all. What that allows us to do is jump straight to when we can see the where the two sides are trying to do their media negotiation and start looking at things like their capabilities, their codecs, their packetization rate, DTMF, all those good things. We can jump straight to that. Let's go ahead and dive in here. We can see our capabilities are really being exchanged at this point. And just like we saw in our other video, there's an alert for a capabilities mismatch, which is due to how we have things configured. And let's just go ahead and mark this real quick. If you wanted to go through and take a look at what the capabilities mismatch is for, go back and reference the other video. We talked about everything in terms of the party 1 cap count, party 2 cap count, what these numbers mean. But for this video, we're just going to move forward. As we go down a little bit further, we can see that they are going to try to allocate a transcoder. And we can see down here where it says allocate transcoder, we also get the CI for the transcoder. And then I'll mark that with style token 3. We'll save it. And right here we see that Media Manager is going to engage Media Resource Manager. This is for the Media Resource Manager allocate transcoder resource request. So this is where the Media Manager is requesting a transcoder from Media Resource Manager. Scrolling down a little further, we can see that it's going to reference the MRGL, and within the MRGL, we see two different media resource groups. So the MRGL is Media Resource Group List, And then within a media resource group list, we have different MRGs, which is short for media resource group. I put that MRG in there because I named this media resource group. I also named this media resource group. Now, transcoders can only be on hardware in DSPs. So we know that the software MRG is not going to be used. That's where MTPs can be, enunciators can be in there, software conference resources can be in there, but my hardware conference bridge resources and other devices that are hardware are going to be here in this MRG. So now we see that it's going to get a transcoder from the default list, and that device name, which is a name that I gave it, is going to be my universal transcoder for RTP. There's two different types of transcoders. There's just your bare bones standard transcoder, and then there's universal transcoders, which universal transcoders can be used to transcode between the same codec. So, like there's times where in a call flow, a transcoder will be in the call flow and both sides are using G729. I can't think of a scenario at the moment when that happens, but I've worked on issues when that has happened and we had to use a universal transcoder in order to let those two sides talk to each other. Now we see that Media Resource Manager is going to create the process named Media Resource CDPC. Whenever you see a process being created for your call, that is going to be a sub-process that is specifically for your call. It will actually end when your call ends. And we can also tell that this is associated to our call because when we highlight this here, this block of different lines of logging, we can see that our CI is here. So this is the first line in the block because of the 3 zeros. And it looks like number 9 is the last block or the last line in this block, but these are all associated. So that lets us know now that Media Resource CDPC is created for our call. And they're going to try to get this media resource request handled. We should be able to go down a little bit further and see where the request is actually getting a response. I'm going to highlight this one here, which I believe is the one that was ours. Let me go back and highlight it. I'll highlight it as style token 3. Now they're still going through the request. They went to media termination point control. Let's see if that one was created for our call. It doesn't look like it. And at the end of all of this, we see here that the allocate resource request failed. There's another iteration where it starts looking for resources elsewhere. And this one was successful. So here we can see the allocate MTP resource response. And specifically, we can see that they did use the universal excoder for RTP. Let's turn on word wrap real quick. Within here, we can see that device name, and we can see that it has 10 different capabilities. We can see what region it's in. It's the default region, just like what somebody had commented in the other video. They said, hey, I went ahead and I started looking at the successful logs. I believe that everything worked now because the transcoder was moved to the default region. So yes, it looks like you were correct. I'm going to add this up here and we'll save it. I'm also going to highlight the transcoder's name as style token 3. Well, I guess I got 4 on that, but that's okay. So now if we go down a little bit further, let me turn off word wrap. We can actually see where we're about to see the CI for party A and the CI for party B connecting with the CI for the transcoder. So as you can see here, this is our first CI, that's our second CI, and they're both going to get connected with our transcoder. Let's now highlight the CI for the transcoder and we'll do Control-Shift-F. And then we'll search for that. So we can see here's where it failed. The requests keep going, and then here's the responses. Then down here, we start getting to the area where we'll start to see the codecs being exchanged and compared. While we're here, we can see up here it says party 1 CI is going to be the CI that we had for our calling party. Down here though, calling the party 1 CI is going to be the CI for our called party. So when we have the transcoder being allocated, it's two different parties being connected, and you just have to make sure that you're aware of which one's considered party 1, and the party 2 CI is going to be the transcoder. So now I'll mark up this line here. We'll just mark it as party 1 CI and party 2 CI. Then we'll do the same for when our called party is being connected with the transcoder. Party 1 CI, party 2 CI. And then I'll save this and we'll put word wrap back on. Now looking here, we're not going to see the codecs for the two parties just yet. They still need to query the two different sides for their capabilities. And we can even see down here that there's a media exchange agena query capability. Let's go on down here to the media connect reply. We can turn off word wrap, and then we'll scroll just a little bit down after all of the interface capabilities is done. Then right down here, we can start seeing some of the capabilities actually being exchanged. Now we can see cap A count 10 and cap B count 11. Same here, cap A count 10, cap B count 11. Let's go ahead and highlight this. I believe this is phone A. Yep, 109 is phone A. Start token first. Let's see. And then right here we have, I believe that is the IP address of the gateway. It is, which is also going to be the IP address of the transcoder, because this transcoder is on the SIP gateway. Now on both of these, you can see that it says cap count equals 1 and caps equals 4. That's the one that they agreed upon. You can see it up here. And then we end up going on into the next file. You can see this file ends here. And on the next file, we start getting into some of the skinny type of messages. Where here we're seeing an open logical channel, and that's going to from MTP agena interface to the media termination point control. So our MTP agena interface is telling the MTP control that we need to open the logical channel. What we expect to see with this is the logical channel should be opened, the receive channel should be opened. We should see some things like a start talking ACK, or sorry, like a start media transmission ACK. And if we go down here a little bit further, we actually do see those things. So we have the open receive channel being opened. We have the start media transmission being sent to the device, the start media transmission ACK. And then down here is where the call is actually being torn down. Let's go ahead and take a little bit of a closer look at some of these skinny messages that are going on. Before we start looking for those skinny messages, there's something important that I want to note about this media termination point control. The numbers here are going to align with something called the TCP handle. And on the skinny side, the TCP handle is something that is going to be associated with a specific device, and it's only going to be for the time that that device is registered. So it's not going to be specific to a call, but it is going to be specific to a device for a period of registration. So I'm going to do a Control-Shift-F on this. And we'll just do a quick find in files. Oh, not replace in files. We want to do find all. And now with searching on that, we can see a lot of really good information as it pertains to the transcoder. Now, I want to show you how much easier it is to see things when we search on this piece here. We can see where the media termination point control is created. We can see some of the station init information, with which station init is something you'll see in Skinny. And this means that it's a message that is originating from the Skinny device, which in this scenario is our transcoder. So the transcoder is sending something to the CUCM. I'm not too concerned with what it is. I'm not going to look at it. If we see station D, then that means that the CUCM is the one that's sending something to the device. So you can look at it as the station is initiating a message, or you can look at it as the station is the destination. Station D versus station init. Let's go ahead and scroll down real quick. We can see where the allocate MTP resource request is occurring. Everything is listed out very easy for us to see it. We can see the transcoder's capabilities as well as the device's capabilities. Furthermore, we can see the transcoder's capabilities again versus the other device's capabilities. And then we can see for match 1, we have 6 matches, but for match 2, we only have 1 match, which is right here, 4 and 4. Up here, let's see what they are. We've got 16 and 16, 15 and 15, 12 and 12, 11 and 11, 86, 86. So you can see how those matches are there. But down here a little bit further, we see that there's an error and the allocate MTP resource request failed. We already noted that. And we can see that the error bit set is being set to 0x2. So they go on and they try to allocate the resource from somewhere else. And down here we can see that it actually is successful. So this is going to be the device that we use. Now we start getting into the Skinny stuff that we talked about, where the media exchange Agena open logical channel goes to the device, and then we also start seeing things like start talking, and we should see messages coming from the device right here. Open receive channel ACK. So it was told to open its receive channel right here, station output open receive channel. And right here we see station init open receive channel ACK. Here in this message, the device is going to tell us its IP address as well as the port that it wants to listen on. So it's going to receive media. The transcoder is going to receive media at this IP address, and it's going to receive it on this port. So I'll do style token third and style token third. And this is something that we should see, going throughout the whole call. And we should be able to go into the SIP signaling and find this port in the SIP signaling. It looks like right here. So this is going to be going to which party? 109. So this is an ACK, or actually it's a 200 OK that's being sent to party 1, and it's telling party 1 the IP address and port of the transcoder so that they can talk to each other. If you want to, I put the gateway information into the file as well. So if you would want to go through and take a look at the gateway stuff, that's going to be right here, data from router. And in here you'll see things like show SCCP connections, show VoIP RTP connections, show call active voice compact. Now it shows that there's 4 different call legs. And if we take a look here, that's going to be because the call is going out it's coming in on the SIP gateway and going out to the telco. It's going over a PRI. And then this one here is going to be the inbound SIP call. So we got the VoIP leg over here for the call, and we got the PRI leg here for the call. And these last 2 call legs are actually going to be for the transcoder here, which you can see that this is going to phone A, and then this side is going to the router itself. And that's because the transcoder and the gateway are one and the same, which is why the output for show VoIP RTP connections right here may seem a little bit confusing, because we see the same IP address 3 different times, but on one it has the local RTP port, which is the same as the remote ITP port here, and then the local RTP port down here is the same as that. And that's just because the transcoder and the SIP gateway are still 2 logically separate devices, but they're the same physical device. And so it's essentially sending RTP from itself to itself. Anyway, there's all sorts of debugs and show commands here in this file for the gateway side if you wanted to go ahead and look at that. I'm going to end this video out here, and I'll see you in the next one.